What's up, you cool cats and kittens? I'm Thomas.
And I'm Zach, and welcome back to another
Two
episode of
projects.
CS120 Projects. And this is
Final project.
our project, and I'm Zach.
And I'm Thomas.
Okay, to the
All right.
project. Okay, this is our program. Our program tests the efficiencies of 3 different implementations of the same algorithm, ksum. It also tests the differences in efficiencies between the language Python and C++ with the same implementation. We implemented ksum quadratic in both. Okay, read me. So ksum is an algorithm that takes an integer k and a vector of integers, and then it will return the unique pairs in that array that's sum up to k. As you can see, if k equals 10 and the array is as such, the solutions will be all of these. There are many repeats and there are reversals, but when it outputs, it'll only output the unique solution. So 194655. That includes no duplicates, no reversals. Okay, to ksum quadratic. So ksum quadratic is just a brute force algorithm that takes 2 for loops and just tests every index against every other index. If it gets a sum, then it will add that to solutions, then print out solutions, but only print out unique and reversal. And the top of these files are all just pieces of code to take in all the numbers from numbers.txt and put into array. We can go to numbers.txt right now, actually, before we move on. So this is just a large list of 10,000 numbers ranging between -50 and 50. But we don't have to scroll through all of them. Okay, now nlogn. So nlogn is a faster one. It is nlogn because the sorting algorithm which is necessary is nlogn that's specified in like the C++ documentation for sort. This just takes like 2 different pointers and keeps going, moving down the list until they converge and it finds solutions. Pretty boring stuff. And at the very bottom, it also prints out unique solutions. And then the linear one makes use of hash maps. It's important to note that this algorithm relies on find being constant time. In this case, do you want to scroll down a bit, Thomas? In this case, because the size, I made the size of the hash map larger than the possible entries, and so finding will be a constant time operation, which is key to making this a linear time algorithm. This just works with 2 different hash maps comparing complements and keys and values, and at the very bottom, it will again just print out unique solutions. And then one more thing, in main, we implemented quadratic again, just so that when we tested, we could observe differences between the languages. We tested by timing how long it took each implementation to compile and then run and then output, and then we set the timer. So each one has its own timer, and at the very end we compare the 4 times that we get.
Okay, so I'm going to talk about how all this kind of comes together in the main.py file. So it starts off with the user input, where the program asks the user for an integer between -100 and 100. If they do it out of those bounds, the algorithms won't return any solutions to that value of k.
Because the numbers range between -50 and 50, and so the biggest possible pair is 50 and 50, which is 100, and the smallest is -50, -50, which is -100. So anything outside those bounds would not return anything.
Exactly. And also, there's an exception for type errors. It needs to be an integer. So, like Zach said before, the algorithms are all timed by using the time module in Python, and we just start the time before the algorithm is called and stop it once it's done doing the output.
Yeah, the implementation for quadratic in Pi is at the very bottom of the file, but it doesn't really matter what it looks like because it looks like the one in the CPP file.
Yep. So the way that we interact with the C++ files from this Python file is the subprocess module in Python. it basically just allows us to, within the Python script, write a command on the command line. So essentially you can just compile a C++ file and then run it using the executable file that's made from that. So each of the C++ algorithms uses the basic structure of the subprocess check output function, and in the executable command, it's given an argument, which is k, which goes into all of these as an argument in the main function, and it is used by those algorithms after that. Started the program on the command line about 40 seconds ago. The first sorting algorithm takes a while to actually work because it's with Python.
And the integer or the array is 20,000 elements long, and so it takes about a minute and a half to run. So we started quite a bit into that time.
Yeah, so sooner or later we're going to start seeing the results from the different algorithms. First one's going to be the Python one, and then the 3 C++ ones will come up shortly after that. All right, so here's the Python, finished in almost 90 seconds. Then we had the nlog-n C++ one, which was 3.4 seconds. Then the linear one, which took 3.27 seconds. And coming up shortly is the quadratic C++ one, which took about 11 seconds.
So yeah, we looked for every discrepancy we could, and we could not find a reason why the quadratic in Python took about 9 times longer than the quadratic in C++. The timing is where we start the timer and end it is consistent. Everything else is consistent. The only variable here is the language used to code it, and so that we assume that's what causes the ninefold difference. But looking at the other ones, you can see that the linear solution is the fastest by 2 seconds. The nlog-n is a close second, and then the quadratic in C++ is significantly slower than the middle two. But that is expected because of the time complexity differences.
All right, and that is pretty much our program.
Pretty much it. You can see that the outputted vectors are the same. They're not sorted because they take a lot longer and add a lot of complexity, but they are the same. We timed them. You can see the differences there, and also the differences in the languages used to code them, what those efficiencies are. But that was our program. There's more details in the README, and the algorithms are commented as well in the code, so you can read it there for more details.
All right.
Awesome.
Thanks for watching.
Smash that like button.